So these are the practice questions from yesterday, so hopefully you can find this question. I should make sure that I'm in the right spot here. There we go. Alrighty, so we are looking at forces in equilibrium. Remember, equilibrium means when the net force is zero. So it's really, if you sort of step back and look at it, it's not any different than a lot of other questions. It's just that instead of finding the net force and finding the acceleration, you are setting the net force equal to zero and then sort of working backwards a little bit, I think. Ready, Cole? Okay. Two ropes pull on a ring. One exerts a 62 Newton force at 30 degrees above the horizontal. The one other is a 62 Newton force at 60 degrees above the horizontal. What is the net force of the ring? What are the magnitude and direction of the force that would cause the ring to be in equilibrium? So if we label these, I guess, the 30 is first. So how about we label this one F1? We'll label this one F2. And before I go any further, I'm going to do this. Play my little game. Maybe I'll just stand here one time and just do it like this, right? Okay, so we're going to label those F1 and F2. Just looking at the diagram itself, what direction would the equilibrant be? What direction would the equilibrant be? Do you kind of mean like this? Something like kind of like that? And it would actually be a fair bit longer, right? Because it's got to balance those ones off. I just ran out of space there. So yes, it would be like that. So again, the equilibrant is simply the negative resultant. So we're going to add F1 and F2 together. That's going to be our resultant. And then we're going to switch the direction. Okay, so let's begin. How are we going to do these ones? They're sort of at weird angles. We're going to have to use components. We're going to have to use components, right? So let's set those up. I'm just going to make myself some more space here. Hopefully you guys have, I don't think you have a lot of space. You probably want to be doing this on loose leaf somewhere. If you haven't started on loose leaf, right? Okay, so F1 is at 30 degrees, right? So I'm going to label this one F1x. I'm going to label this one F1y. Good and nice review of vector components here, right? Mustafa, this is the part you had trouble with, I think, right? Wasn't it? Yeah, so this is a good review for you. Okay. Oh, you don't have this question from yesterday? Hey. Alrighty, so I'm going to, Billy, we're just working on practice question number 3 and just sort of really getting started here. So that's sheet from yesterday. All right, so F1, let's find F1x and F1y. Again, I like to kind of set up F1x on the left and F1y on the right. So F1x is going to be, F1x is adjacent, so that's going to be cosine. What was this amount? Was it 62? Did I read that right? Am I right? 62? Okay. So that's going to be 62 cosine 30. I don't have enough room to go left and right, but that's how I like to do it. Help me out here, gang. I really need to put a calculator here in the drawer and leave it here. Make sure you're in degrees. .7 is good. And it's to the right, so it's going to be positive. Then F1y is going to be opposite, so that's going to be 62 sine 30, right? Positive or negative, Nate? Yep, up, so positive. Okay, so that's our f1x and our f1y. Now we got to do the same thing for our f2. I like drawing the triangle. Do you need to draw the triangle? You don't need to, but I think it's a good visual. Doesn't need to be to scale. So f2, this is 60 degrees now. f2x, f2y. Again, the force is 62 newtons. Let's do our x first. F2x is going to be 62 cos 60. And I can actually do that one in my head. Are you impressed? Because I know that the cosine of 60 is the same as the sine of 30. Am I right? I know. Yep. That's why they picked 30 and 60. I've done this question a few times too. F2y is going to be 62 sine 60, 53.7. Again, all positive, right? To the right and up. Okay. We're just doing vector addition here, that's all, right? That's all it is. Okay, so resultant x is going to be 53.7 plus 31. And resultant y is going to be 31 plus 53.7, right? See if I can do that in my head. $84.7. Both the same. To the right and to the up. Do I need to draw the triangle? Probably wouldn't hurt, especially at this point, as I'm demonstrating for you. It's a 45-degree one, right? Is that called equilateral? I always forget. Equiangle. Yeah. 84.7, 84.7. Resultant. So r squared is 84.7 squared plus another 84.7 squared. Emma got an answer there? No? I thought I saw you type it now. Josh is going to do it for us. $119.8, and I guess that would be newtons, wouldn't it, right? Okay, so that's a resultant. We got to find our angle here. Let me finish this question, guys, then you can talk baseball. Come on. Theta equals inverse tan. Observe. Do I even need to do this? I mean, I'll show you the work, but we all know it's going to be, or you should know, it's going to be what? You should know that it's going to be west 45 north. Not west. Now, really, is it east, or is it west and east? I think in the original question, if we go way back to the top there, don't they just talk about above the horizontal? Right? So really, it's not really east and 45 north. It's really 45. Do you guys know the abbreviation for above the horizontal? ATH, above the horizontal. Sorry, man. I'm not as cool as you think. Oh, yeah? If I like this, I might just use this in the future and call it the Mitch Project. I just might. Like that? Okay. I'm going to let it grow on me. I'm not convinced yet. We'll see. We'll see how it goes. I'm used to ATH. Okay, so now this is actually the resultant though, right? So what is the equilibrant? E would be, what's the number? 119.8, and it would actually be below the horizontal. For the purists out there, I'll write DTH. Hard question? I mean, really, what's different about this than the ones we've done before? Really nothing. All we've done is vector addition and then done a little flip thing at the end, which you already sort of know how to do from vector subtraction, right? Well, it is, and I guess it isn't, right? I mean, technically the BTH is the direction. I mean, it really depends, Billy, on how the question sort of sets up the directions to begin with. If you said minus, I wouldn't mark that wrong. Like, I think that shows good understanding that it's opposite. I'm good with that. That's just sort of your system. I think I'm good with that, but it doesn't have to be. Yeah, good question. Okay, how about I let you try number 4 for a few minutes on your own and see how you do, and then I'll do it for you. How does that sound? Yeah, this one's pretty much the same. There's no picture, though. 2 forces are exerted on an object. 36 Newton force acts at southwest. When it says southwest, that means exactly 45 degrees. And when it says 48 newtons at southeast, that also means exactly 45 degrees. I'll give you a few minutes to try that, and then I'll do it, and then I'll give you the rest of the time to work. It's pretty much the same thing. It's just slightly different numbers, right? But the setup, the basic idea is pretty much the same. Okay, so let's have a look here at practice question number 4. Again, very similar to practice question number 3 in that we've got 2 forces, and all you have to do is find the equilibrium. Okay, the one thing that's different here is there's no picture, right? So it's a 36 Newton force acting at southwest. Southwest is down and to the left, right? So like that, let's call that one force 1. And it's 36 degrees. 36 newtons. It just says southwest, so that tells us automatically that it's 45 degrees. So this one here is going to be F1x, and this one here is going to be F1y, southwest. Yeah, I did it right. I think I might have left myself enough space here. F1x is going to be opposite. So that's going to be 36 sine 45, and I probably should have went and got a calculator. Oops, Nate. How much, Mustafa? 25.46. How about 25.5? And that's going to be to the left, so we're going to make that negative, right? Mixed them up? You're right. It's not going to make a difference, Nate, because it's 45. And in fact, you would probably slip that past me on a test because I wouldn't bother checking. Having said that, I probably won't make it 45 degrees. So. These are vectors, man. Yeah. This is the part 2 of the test. Yeah. Okay, so this is also going to be 25.5 negative. Well, all of the concepts are very similar, right? Okay, they're both negative. Let's do F2. It is southeast. Again at 45 degrees. F2x, F2y. I don't know. Southeast. I did it right. Well, okay, east, south, same thing. Same thing. Same thing. This is 48. You're going to get the same answers. F2x here is going to be 48 adjacent cos 45. Somebody help me out. 33.94. 33.9, we'll say. And that's to the right, so it's going to be positive. F2y is going to be 48 sine 45. Mustafa, you're the man with the calculator? Oh, I knew that. Why did I ask? I knew that. 33.9, but that is down, so that one's negative, right? Okay. I like to do this when I have a chance. I got the columns. Okay, so that means then that resultant x is going to be 25.9. I still have that habit of trying to wipe it off with my hand. 25.9. Oh, hang on. That one's negative, right? It's not 9. It's 5. I did it again. Minus 25.5 plus this x here. 33.9. You ladies are good back there? Okay. I'm not. I'm just making sure. I'm not too worried. 33.9 minus 25.5. I might be able to do that in my head. 4. 33.5. 8. 8.4. Yes. Ry is going to be minus 25.5 and subtract 33.9. I think I can do this in my head. We'll see here. 9 and 5 is 14. Carry 1, 8, 9. 15 minus 59.4? On a roll. Okay, now there's a couple ways to do this now. If you want, we could do the flip right here. Do you want to do that? Should I show it to you this way? Just something different here. Let's just show it to you this way. So what I could say is, because the equilibrium is in the opposite direction, could I then say EX is the opposite of 8.4, which is minus 8.4. Could I do that flip? We could do it there if we want. And here EY is going to be not minus 59.4, but 59.4. Now I've got my components of my equilibrium, EX and EY. Minus 8.4 is this way, 59.4 is up, so it's going to be like a little bit this way and a lot that way. Like so. You like that, Nate? There's nothing like a good component question. Yeah. My what? Okay. No, I got EY is 59.4 right here.
Why do I have opposite of that? What's my Y?
I don't know. Someone help me out here. I can't guarantee this is the right. Have I made any mistakes? 60? 60 newtons, I guess, right? And we do need to find this angle here. So theta is equal to inverse tan, opposite over adjacent. 59.4 over 8.4. $82? Does that seem reasonable given those numbers? 60 and 8? I think so, right? So that's going to be west. West, what was it, sorry? 82? 82 north. Hey, let's check the answer. See if I did it right. Did I do it right? I got the answer from the back row. 60 newtons at west, 82 north. There you go. Okay. So again, I just did it a little bit different in that I flipped the Rx and the Ry to get my equilibrium. If you want, you can just do the resultant as you normally do. Find the theta as you normally do, and then just flip the west and the north, right? Which would have been, I guess, east and south, but either way is good. Okay, I'm going to be quiet for a while. I suggest there's 5 practice questions on the next page. I suggest that you try those. Again, tomorrow, you guys out there in Winnipeg, and Grammy, you'll have the work period. There are some textbook questions that I would like you, these are the ones here you should do, these 5. There are some textbook questions that you should do. I'm going to make page 237, number 4, mandatory. Okay, that's an important one. And I will go through that one. Maybe as a group, we'll maybe do that Friday, the tail end of Friday. Can we write the second part of this test on Monday, and that gives me a little bit of time to mark for my Wednesday deadline?
Yeah.
Okay, so let's plan for test on Monday. Those of you that wrote part 1 only have to write the last little bit. Those of you that didn't write part 1, well, tough luck, you got to write the whole thing.
Hey, sorry.
Yes, Nate.